Hello friends, this is your Jagan sir and I am going to discuss NEET 2026 question paper daily 1 PVQ under daily 1 PVQ session, and today we will see first question in the NEET 2026 question paper. See beta, for a simple pendulum having time period t, the variation of kinetic energy with the time t is represented by. Before we are going to solve this question, I would like to tell you with an example. See, suppose here a spring mass setup is present. Now I am giving certain amount of velocity here. The object will reach us up to here and again up to here. We know this is the amplitude, and the separation from amplitude at a location we can represent like x is equals to a sine omega t. X is equals to a sine omega t. Now, if I am finding its velocity by differentiation dx by dt, a omega cos omega t. Clear beta? Right. Now, see Nana, if object starts from mean position, we are using this formula. If object starts from extreme position, we can use x is equals to a cos omega t. That is different. Forget about that. Now, for the question, let us first consider here the thing is they are asking us to tell the kinetic energy and which graph suits its kinetic energy value. Now, kinetic energy is equals to half mv square. That is half mv value is a square omega square cos square omega t. Omega t. Now, see here, we can write it is half m a square omega square 1 plus, otherwise for your clarity I will write one thing, by using cos 2 theta we can write it as 2 cos square theta minus 1, then 2 cos square theta is equals to 1 plus cos 2 theta. That means, see Nana, can I write now cos square theta is equals to 1 plus cos 2 theta by 2. So similarly, we can write cos square omega t is equals to 1 plus cos 2 omega t by 2. Yes, ma'am. Therefore, kinetic energy is equals to half m a square omega square 1 plus cos 2 omega t by 2. Therefore, obviously here by 2. Therefore, the angular frequency of the SHM or pendulum is 2 omega. Therefore, its time period becomes t by 2. T by 2. Right. And come here, we need to verify out of the given options which option suits us with this time period better. With this time period. See Nana, first option is giving negative kinetic energy value. And obviously here velocity is positive. So this term remains positive always. That means this term remains positive always. Am I right, beta? So obviously you can consider here first one is not the correct answer, and second one is giving one is maximum value, one is minimum value. But according to our representation, in both the cases, it should be maximum only. That means, as they said, a pendulum from mean position it is started, then at extreme position velocity is 0, at mean position velocity is maximum, And for your understanding, instead of this representation, I used spring mass system beta. Chalo, if we, according to this question, now according to this question, we can say here it is giving negative kinetic energy, so first one is not correct, and second one is giving maximum value at one point and minimum value at other point. So it is not correct because we have square terms. Obviously, this give equal for both the cases, means either object is moving like this or like this. The magnitude of the kinetic energy remains constant, remains same. So second one is also not correct, and third one is giving constant value data. Actually it is changing, velocity is zero and velocity is maximum. It is also not correct because it is saying constant kinetic energy. Then the final option is option fourth is the remaining, and it is giving time period c beta. What we found here, time period is t by 2, so here up to t by 2, and maximum, minimum, maxima condition, minimum 0, minimum again maximum again 0, again maximum again 0. So ultimately within t by 2 time it is following the complete circle. So option 4 is the correct answer. Chalo, have a great day beta. We will meet again with the next session of daily PYQs from Neet questions. Have a great day, take care, bye bye.